First let me thank you for inviting me and having me here. My name is Lotzi Bölöni, and I'm going to talk about some of the stuff I'm doing with regards to autobiographical reasoning, the Xapagy cognitive architecture, and I'm going to also try to think through a couple of things. What does it mean for larger implications, and in particular implications for the global brain? And I apologize in advance for the mess which I might make from the global brain idea, which I don't understand quite that well, but please correct me whenever I'm going out on the deep end. All right, so it's going to be introduction, strategy, speculations, and questions. So, all right. So let me start first about telling you where I'm coming from and why I'm doing this kind of stuff. So, okay, my background, bachelor's in computer engineering from Cluj, Romania, and then PhD in computer science from Purdue. And then I've been working for a Silicon Valley startup in the boom years, and then I'm an associate professor at the University of Central Florida of computer science. And then I have been visiting research at various places like the Hungarian Academy of Science in Neuro, Mimetic Computing, and the Imperial College at La Sapienza. So as a technical background, I'm a technical guy. I'm a computer scientist. I am doing autonomous agents for my PhD, and so distributed system AI applications of all kinds of stuff. So that's in hardcore computer science. The kind of funding which me and my students are getting are typically from National Science Foundation or the US Army Research Lab on things like human-robot interaction and human teamwork and modeling social behavior with the benefits for robots and stuff like that. Which obviously determines what are the kind of stuff my students are working on, and these are again mainline computer science, robotics kind of stuff. Now the Xapagy project, this is a personal project for me, which I'm doing for I think the last 6 years or so. Which had not been funded up to this moment, and which allows me something that I can have a longer planning horizon, meaning that I don't need to deliver a result now in the next 6 months, deliver a paper, deliver a working code, which means I can ignore deadlines, trends, publication requirements. On the other hand, it allows me to rethink some of the assumptions behind cognitive architecture and AI in general. And this is obviously a high-risk thing, but I think it also needs to be done. So what's the story here? Well, first of all, in the 1980s, AI was pathetic. That's why funding had been cut. Nothing which they promised had been delivered. These days it's different because the specialized AI, like solving particular problems, a lot of these things had been very successful and actually had delivered significant economic value. Like obviously chess programs with grandmasters, by this time it's not even funny. They are like running circles around humans. Google Translate works quite fine. The whole Google infrastructure regarding based on statistical natural language processing works at some degree. Certainly delivers economic value. Then you have this kind of assistants like Apple Siri, which uses heuristics, speech recognition, diagnostic models, probabilistic reasoning, and so forth. All these things work. IBM Watson works at playing Jeopardy, and then they are also claiming to answer general purpose questions in fields such as medicine and something like that. But now, this is basically looking answers in big data. So you gather a data set which is basically everything anybody had ever written, and then you put it on a data structure and you search for it, okay? So this kind of search and probabilistic reasoning and other stuff works very fine. But general purpose AI is not successful, so we are still very, very far from delivering an intelligent entity. In fact, we don't seem to be any closer than we had been something like 30, 40 years ago when this field started. So the general purpose AI, I guess, if we take Alan Muir's definition that the cognitive architectural system which models all of the human cognition, or in practice, let's shoot for a significant part of it. There have been many architectures proposed, SOAR, ECTAR, Sigma, recently Rosenblum, OpenCog by Ben Goertzel, Icarus, Pat Langley, Polisky, bunch. And there are a couple of, if I look a little bit, I can find 30 more. And many others. And then in recent years, there had been a general resurgence of the area in recent years. Some of these systems, like SOAR and ECTAR, had been around for 40 years, from the 1970s or the 1980s or something like that. So, who am I to propose yet another one? Now, do we need yet another architecture? And there can be some arguments that the existing ones have a bunch of problems. Like, one of them is programming language decisions made in the 1980s, written in word-style languages. That's not really a big problem. We could rewrite them. There is the problem of feature creep. If you look at how a SOAR diagram looks like, it's like every time a PhD student graduates, it acts another box, and when you do this for 35 years, that's a lot of boxes. For this one, so there are, like, for instance, dozens of memory and reasoning models, and I'm going to hammer down on this thing. Of course, they are not quite that much needed, probably, so that's no need to start from scratch. You could do a cleanup on those if you really wanted. Or, what I'm trying to do is to try to build from different foundations. And this, of course, is a high-risk proposition, and that's why I'm doing it in my spare time. So I'm going to make two big claims which are going to be the theme of this talk. And one of them is, both of them are somewhat controversial, the second one is very. So the first claim is that stories are the foundational element of human time cognition. Meaning that we live through stories, the way in which we are thinking, the way in which we are reasoning is essentially based on the manipulation of stories, or if you want to call them narratives or discourse or something like that, that's also fine. I don't want to use narrative and I don't want to use discourse because that immediately puts me in a certain box, philosophically speaking, and story is a kind of like a more, let's say, neutral thing. But we are talking. So the arguments I'm saying is that we see our lives as a story. So when you are thinking through your big time cognition or consciousness, your consciousness is essentially you see yourself as a participant in a story and so forth. Our plans, our remembrances are kind of stories. And there are technical things like we can remember stories better than anything else. Our ability to remember things like numbers or images or something like that is simply appalling. Like we cannot remember a telephone number, okay, seven digits. On the other hand, we can remember long stories and we can recall them quite well. And in addition, even when we are teaching ourselves things like math, we are best learning even math or other things through examples, through stories, rather than just looking at formulas or tables and rules. You always need to understand it and have the ability to explain it to our grandmothers, as I was saying during the lunch. So this is relatively non-controversial. Here's the second one. I'm going to claim that the unprocessed autobiographical memory is the foundation of human time cognition. Meaning, whatever you have ever seen in your life is stored in your brain in an unprocessed way, and that's what your brain is going to use. Now, this is weird, okay? I know it's weird, but I'm going to try to argue a little bit for it. it is relatively uncontroversial, okay, that the human behavior is learned. I mean, we have instincts and stuff like that, but for better or worse, most of what we know is something learned, so we acquired it through our autobiography. But normally, the way in which people believe this is that we are processing that, and we are creating theories in our minds, and we are creating. We don't just store all this autobiographical stuff, right? We have semantic and procedural memory and stuff like that. And I will argue that we don't need semantic or procedural memory. And this is, I am aware that this is very controversial. Now, let me give a quick example, for instance, about what I'm talking about. Does a computer have a picture memory? Well, I'm a computer scientist, I can tell you it doesn't have a picture memory. What it has is number boxes in which you store bits and bytes. That's not the picture memory. Now, what you have, but of course your computer is going to take pictures, right? It's happening right now, and it can reproduce pictures. But the fact that looking from outside, you are taking pictures and reproducing pictures, it doesn't mean that you have a picture memory. It only means that you have some procedures which translate what is outside into some kind of internal representation, which doesn't look at all like a picture, and then it's going to be translated back. So now, it is still a useful metaphor. I can talk about my computer having an image memory, okay? So, for instance, the psychologists can say that you have a semantic memory and a procedural memory and stuff like that. That's a useful metaphor from outside. But if you actually want to build it, then you actually need to know whether it is or it is not. Things like psychological tests based on brain damage, which people are doing for a long time, they are useful, but it can mislead you. For instance, you yank out your video card from your computer. Well, your computer is still working. The only thing which doesn't go is doesn't show pictures anymore. So you could come up with the idea, well, I yanked out the video card. I can still log into the computer. So I yanked out the video card, pictures went away. That's where the pictures are stored. Well, they are not. Okay. So the point here is that just because from outside I can see some behavior, it doesn't necessarily tell me that internally it's going to have a structure. It doesn't. All right. So of course this doesn't prove anything. Any proof would have to be constructive. So let's go and build a system which doesn't have all this, and if it works, it works. Now another question that you might ask, I just said, well, what about performance, right? You say store everything. How can you store everything? Well, it turns out that storing everything is sometimes easier than trying to do semantic memory. For instance, can we afford to store the full autobiographical memory of an agent? Well, we don't. You see, we don't want to store all the data humanity had ever produced. What you need to store is what you have seen. And what you have seen, at least in a story form, is not that much. If you write a narrative of a human life experience at a rate of something like 1 sentence per second, and I don't know, you make a 30-year-old person, then you are going to have something like 600 million sentences. Well, that can be stored anywhere. And I can store it in a RAM, not even on the hard disk on my computer. So again, how many stories are relevant at any given time? And you don't need to have quite all those stories. For instance, an airline pilot is required to have 1,500 flight hours. And a surgeon, when it goes to operate on you, it had probably had something like the experience of 1,000 surgery hours or something like that. And the trial lawyer will have an experience of maybe 100 cases. So there isn't quite that much experience stored. The relevant experience can be comparatively quite small. Of course, these are complemented by books read and other stuff like that, but that's again not that much information if you think about it. Now, again, still wouldn't be the procedural memory and semantic memory will be a more compact, nicer representation, right? Wouldn't semantic be smaller? And of course, all of us in these fields, we are really envying the physicists, right? We just love this kind of stuff that you throw up something like E equals mc squared, and well, it seems to explain everything. But unfortunately, that's for physics. Many other sciences, especially social behavior and stuff like that, doesn't seem to have that kind of nice, you put one single tiny formula and it explains everything. This works in a very few fields. Sociologists have tried to develop a theory of social behavior for ages, and it just seems to be that it's very weak. Okay, so now based on this thing, I started to write code, and I'm going to try to present what I had written. Okay, so Xapagy is a cognitive architecture which proposes to model and mimic the human behavior with respect to stories. And the kind of things I wanted to do when I started to do this was things like witnessing a series of ongoing events, a story, keeping track of the participants, their identity, properties, activities, following the fixed story narrated in a language, for instance, reading a text or listening to other agents' narration, predicting future events in the story, expressing surprise when unexpected events occur, inferring events which for some reason were not witnessed. For instance, understanding narrations where some events had not been explicitly said, like reading between the lines or trying to find the hidden reasons behind somebody's behavior or some stuff like that. Then again, recalling the story, summarizing the story, elaborating on a story, recalling the story in a different way, chaining together different remembrances, daydreaming, confabulating about new stories, self-narrating a story, narrate a story to an audience, adapt the story to the audience behavior. When you see that they get bored, go faster. When you see that they are enjoying it, put in more details and stuff like that. Act as an audience for a narration, stuff like that. Okay? So these are the kind of stuff which I wanted to do. The assumptions, I guess I already talked about them. This time, technically, the only memory type Xapagy has is the autobiographical memory. And the only reasoning model is shadowing. And shadowing is a reasoning technique in which you have the stories which you had previously witnessed. You are currently in the middle of a story, which is stored into something called focus. And then you are aligning stories you had previously witnessed with the current focus. And then, after you have these shadows, I'm talking now, and what is in my shadow is any other talks I had given, and once I have these shadows, I can extend them into the future to make predictions, or I can extend them in the past to try to infer maybe missing events, or I can extend them in different directions to obtain summarizations or elaborations. Now here is a running example which I'm going to use. So Robbie the robot is currently watching on the TV a dramatization of Homer's Iliad. On the screen he sees the fight between Hector and Achilles, while the voiceover narration comments on the story. Robbie fears that the story will end in the death of one of the characters. Good question, why is he fearing that? Now suddenly the program is interrupted by a commercial. Frustrated, Robbie tries to envision a way in which the story ends peacefully. And I'm going to try to explain how Xapagy would handle this kind of story. So the first is the language. Well, because I didn't want to get down into natural language processing, which is a big jungle of its own, I decided to develop a simple language which, however, would allow me to describe pretty much any story except maybe language games, and not the Wittgenstein kind of language games, but jokes and so on, which are strictly related to the language itself. So it's going to have the vocabulary of English, simplified syntax. Only compound sentence is the quote. I'm going to skip on this one. The examples look like this. So you have 4 types of sentences. One of them is subject, verb, object. Achilles strikes Hector. Subject, verb, Andromache cries. Subject, verb, adjective, which can be either Hector is a warrior, which means you discover a new attribute of a instance in this case, or another one is Hector changes dead, which in this case is a transformation, a change of the instance in different instance. And now quotes are used to handle indirect narration. So for instance, a quote, the structure of a quote is that there is a subject who is performing some sort of action in a different scene, like Achilles plans in a future fictional scene that I'm going to strike Hector, or Homer remembers in the Iliad that Achilles strikes Hector, or Achilles remembers in the past scene that I stroke Hector. Now, one of the interesting things that you want to notice here is that, the last sentence, right, there is Achilles and then the I here, which is also Achilles in a way. In Xapagy, these two are not the same. Okay, I'm going to get back to this in another sentence. So basically, the duel of Achilles and Hector is represented like this. I define the scene, then they are fighting, and then Achilles' sword penetrates Hector, and then Achilles is victorious and Hector changes dead. Okay, so the way in which this structure works is that you have these verb instances which are the representation of one of these sentences. There is subject, verb, verb, object, there is an instance which is a subject, there is the verb, what he is doing, and then another instance which is the object. And now the instances represent an entity of the story over the time span limited by the additivity of the attributes. And I understand this is weird, but let me try to explain this. The instances in Xapagy are not entities of the real world. They are entities of the story. Usually when we talk about Achilles, we are really talking, we think that Achilles is one person, okay, or Hector is one person. But it's really, well, what about Hector who is a sack of bones, right? And his bones have been mixed together after burning with the bones of his friend and stuff like that. Is that the Hector we are thinking about? Or Achilles the child, or Achilles the victorious one, or stuff like that? It's very difficult to reason about all these different Achilleses, right? So in case of Xapagy, these are just different instances which are going to be potentially connected with identity relationships, but they are different instances. They have very, very different properties because, well, one of them is a warrior and one of them is a bag of bones and the other one is a child. So the things like, a number of these things which are probably familiar to you from things like the philosophy of personal identity, like views and like somatic identity and psychological identity and things like that, these are actually represented explicitly as relations in Xapagy. So here is an example, like who is Hector? Hector Berlioz, Hector my advisor's dog, Hector the Trojan hero, even within him, like Hector the child, the warrior, the corpse, Hector has seen Achilles' plan to kill him, and so on and so on and so on. Okay. So then you have concepts which represent attributes, and then verbs, and then, so now then you have the focus. And here one quick thing I want to bring into, I think the focus is what in other architectures is called the short-term memory. It basically traces what I'm currently doing. And so what I'm currently doing, I'm here, I'm talking, I see I see Victoria's taking a note, stuff like that. All these things are put together in my current focus. And then eventually they are going to leave the focus. And now, once something leaves the focus, it can never return into the focus. So I do have something called an autobiographical memory, but I cannot recall from the memory. Nothing which I have experienced can be ever recalled per se. I can create a new story which is somewhat similar, but I cannot recall anything. I'm going to skip the scenes because I guess it's okay. So, all right. So whatever I have seen ends up without any processing ends up in the autobiographical memory. And the autobiographical memory is the only memory used in Xapagy. There is no semantic memory, procedural memory, anything else. Now, let's see. How do we work this? Well, we have the story of Robbie watching the fight of Achilles and Hector. So I designed the domain, one-to-one combat domain, which had been some of the basic verbs, and then it had been specifically designed to represent one-to-one combat, meaning that fighting and various types of sword fight, fencing, boxing, stuff like that. And then I have created a synthetic autobiography, meaning that I actually wrote it, which includes a series of stories which are relevant to what Robbie would see. Now, obviously, I couldn't write the whole 30-year lifetime of Robbie, so I just wrote a bunch of stories which he can probably have seen. And these things includes, well, if he's watching a fight, then relevant things are fights. So then I wrote things like the Hector Patroclus and the story, which he probably had seen if he had if he got to the Achilles Hector fight in the movie. And you have things like the Achilles Penthesilea fight, where Achilles kills the Amazon and at the same time falls in love with her. And then you have other stories like the fight between King Arthur and Mordred, where Mordred either kills King Arthur or after wounds King Arthur, and King Arthur goes and is going to come back whenever. And then you have fights in boxing like Cassius Clay versus Sonny Liston and Muhammad Ali versus George Foreman and stuff like that. Obviously, Cassius Clay and Muhammad Ali is the same person, but they are not the same instance. Now, okay, so now we can run this, and then we have the shadows. So the shadows are, well, there is a whole technical story here. They are maintained by something called diffusion activities. So one can see it a certain way of activation, propagation. It's a combination of various techniques, strengthening, scene sharpening, story consistency. And then it does something called probability proportional to size sampling if you have a large number of relevant stories. If you have fights, that's probably not an issue because you probably haven't seen 1 million fights. But if it's something like having breakfast, then you probably had a couple of thousands of occasions of having breakfast, so that such that you won't have shadows with tens of thousands elements. You are going to proportionally and probabilistically sample from the ones which are mentioned. And then this is what you have. So at the end of the story, and this is t equals 822 time. Maybe we can go back a little bit. All right, so here, just before changing that. So the shadows, these are the shadows of Hector. And this is interesting because these are the energy values. The strengths, and these things shows the strength. And as weird as it is, Penthesilea, why is Penthesilea the shadow of the strongest shadow of Hector? Well, by the way, look at here is Hector with the scene with Patroclus. This is another instance connected with an identity relation. This is himself, and still the strongest shadow is Penthesilea. Well, the reason why the strongest shadow is Penthesilea because Penthesilea have been killed by Achilles. And this is the moment where we are. Hector, there is a shadow, there is some value, But Hector had been actually the winner in the fight with Patroclus. And then, so most of the strong shadows are actually people who had lost in fights. Well, except himself is for other reasons strong, because of lack of attribute matching, right? So this is how it works. And then here comes another thing which I'm trying to explain, why this fact that you have multiple instances differs, right? So the instance which killed Patroclus is not the same instance who is fighting with Achilles. Now, this thing allows me to represent plans, fantasies, and alternative narratives. For instance, I can seamlessly represent the instances of King Arthur who was killed by Mordred, and the King Arthur who was more mortally wounded and died at Camelot. That's another version of the story. Or the one who had journeyed to the Isle of Avalon and is going to return. So having different instances representing the concept of Arthur allows me to represent all those stories seamlessly, without needing to try to think about a entity which has different properties which are incompatible with each other. Okay, now once I got the shadows, I have something called the focus shadow link. So what happens is that I have the shadows, and then this is for the shadows of the actions, right? Both instances and VIs have shadows. Now, the VIs, I can try to project the shadows in some direction. For instance, a system like this is that here is what is in the focus, what I've seen now. Achilles' sword penetrates Hector. Then the shadow of this one is that Mordred's sword penetrates King Arthur. And then the projection in the future from this is that Arthur changes dead. And this immediately gives me a sort of a prediction of what is going to happen by projecting in the future. Now, okay, so I said yes, I can predict, but then there is a problem with this prediction because the prediction is about Arthur. It's not about Hector. So what I can do is that by using that link component that Arthur dies, what I can take that prediction and I can project it back to the current story, and that's going to be something called the FSLI focus shadow link interpretation object, which projects back. And so from this one, from that Arthur changes dead, I can project back based on the reverse shadows of Hector and Achilles. And what I'm going to get here are essentially two predictions. One of them is that Hector is going to change dead, and the other one is that Achilles is going to change dead. And given the fact that at this moment, the way the shadows work out, Arthur is more of a match for Hector at this moment, so my stronger prediction is going to be that Hector is going to change dead. So now let's see a little bit of technical stuff here. How many of these I'm going to have? Well, if your shadows, you are going to have something like 10, 20 shadows, that's going to create thousands of FSL objects and tens of thousands of interpretation objects. But then many of these objects are going to have similar or close interpretations, so I'm going to just take some machine learning clustering kind of algorithm and hit them with clustering. So all these things are going to cluster together predictions with similar interpretation. The way in which this is going to look like is again like a shadow, except that it doesn't going to have a head. It's a shadow of nothing. And whatever that shadow of nothing would be, that virtual head, that's going to be my prediction. And now, different kind of links, I can predict for a continuation, I can predict for missing action, I can predict for missing relation, I can predict for summarization, for elaboration and stuff like that. It's a matter of combining different links. Okay, So let's see what are these headless shadows going to be at the Robbie example. Well, because by the time Robbie is dead, by the time Hector is dead, it's over. I stepped a little bit back, and instead of that, I looked at the headless shadows like 3 steps before. And this is at the moment in which Hector is becoming tired and Achilles is launching an attack. So the 8 strongest continuation headless shadows look like this. 9, 6, 4, Achilles is victorious over Hector. 0, 48, Hector changes dead. 4 on 12, Hector concedes defeat, and so forth and so forth. Now, there are also predictions, by the way, that where Hector is going to kill Achilles, by the way, so only that with a low probability. Now let's see how can Robbie imagine that he's going to, how can Robbie continue the story? Well, the way Robbie can continue the story is simply by taking the strongest continuation and instantiate it. Say it aloud. Once it does that, then these continuations are going to change, and then it's going to pick the one which is the next strong, and so forth and so forth and so forth. And what I'm going to get in that case is going to be like this. It's not quite what ended up in the story, because, well, it doesn't know which way actually killed him, but it predicts that Achilles will be victorious and Hector is going to be dead. Now, predicting exactly which way he's going to kill it, that's a different story, right? Movies are making a mess out of it, like Iliad says that he was killed with a lance to his throat, and the movie was with a sword, and so forth. So, but anyhow, this is roughly corresponds to the way in which the story will unfold after the commercial break, albeit lacks the details of Achilles killing Hector. Now, what if I want to predict a different outcome? Well, if I try to find a non-violent end, we can proceed by choosing to instantiate continuations which are, for instance, non-violent. For instance, let's try to find continuations which are typical of fencing bouts, which I had seen, like Olympic fencing. People are victorious, they concede victory, something like that, but they are not killed. So what I can do is I can pick the continuations by choosing the third one, where it says Hector is going to concede defeat. That's not how it turned out in the Iliad, but it could have. And then the next time I'm going to update the continuations, it's going to still have this Achilles victorious, but it's going to be one which is Hector shakes hand. And where does that prediction coming from? From the fencing bouts I had seen, right? That's like the second one. And now, after that, it's going to be Achilles is victorious over Hector, and notice how the Achilles changed that became much, much less likely. So it's enough for me to twist my narrative a little bit, and after that, once I twisted it in a certain direction, after that it's going to continue down on a different road. Okay. So that's kind of what I wanted to show. I can show you how this works on in a demo, but now this is the moment in which I am going to do something which I can less do on purely technical talks I gave, so that's why I'm happy to be here, and I'm going to try to discuss a little bit of more like a speculative discussion about what a system like this might imply. Okay, well, I'm going to make some total assumptions, and again, I'm not like a crazy-eyed guy. Obviously, all this thing can be wrong and stuff like that, but let's play a little game, and let's assume that the assumptions I made are correct. So I'm going to make the assumption that human cognition works along this line of the autobiographical reasoning hypothesis. And then I'm going to make the assumption that this model is implementable on a computer, meaning that I can actually continue doing Xapagy up to the moment in which it can match human reasoning. So let us see where these assumptions lead with regards to human cognition and global brain. Now, a couple of things. First of all, can we trust our memories? Now, the question is, where are our narratives coming from? And of course, they are coming from a number of places. There is first-person experience, includes physical sensing, the kind of stuff which I did. Then there are things like witnessing, things where I have been present at events but not directly participating. Right? I've seen a sword fight. Then you can have indirect narratives, things which I have been reading or listening to or stuff like that. Then there are my recall narratives, and the way in which it works is that because I can never really recall something from the memory and put it in my focus, what I can do is I can create something which is similar based on my memories. So that's going to again be added back to the list of stories. And then in addition to this actually recall stuff, I can have imagined narratives, daydreaming plans, consciously constructed stories from scratch and so forth. You change the system in such a way that it picks more or less randomly from the continuation, you are going to end up with weird stuff. Okay. So now, at the moment when I'm in there, right, when I'm doing this first-person experience, I know, of course, that it's a first-person experience. But because the assumption that this is all autobiography, it means that these things are going to be recorded exactly the same way. So there is no really fundamental difference between things which I had experienced firsthand versus things which I had experienced secondhand versus things which I had just heard about. Which means, and furthermore, when I keep recalling something, after a while, I'm not remembering my original experience. I tend to remember what I have recalled. So if you do this sufficiently many times, at some moment it's very difficult to figure out what had been a physical experience you had participated versus something which you read about or something which you had told it so many times in a different way that you seem to remember that actually happened in ways like that. And we know that this is a psychological provable fact, that this is kind of what humans are doing. Now the next question is, do we know why we are doing something? And well, remember that shadowing is not recall. Just because we are shadowing something, it doesn't mean that we actually know that the shadow is there. It just affects our views of the continuations and stuff like that. So whatever is in the focus is what I would call conscious behavior, or we are conscious about it, but the shadows are not conscious. Which means that our memories influence us even if we do not believe them, even if we do not realize that at this moment they are shadowing what we have seen, and also if we cannot recall them anymore explicitly. These things do influence us, and we can start a number of speculations from this direction with regards to how all the Freudian stuff, right, but other stuff as well. Okay, now the next question is, do we care about the truth? And well, these are just stories, right? And these stories, truth value of the stories, you can assign a truth value to the story, but that's just one parameter which you assign to the stories. In fact, things which are not true are such a big importance on our lives, right? I mean, all the movies we are watching, they are not true, right? So the point with this one is that the truth is just one of the many annotations, in addition to balance and interestingness and stuff like that of the stories. It is not a fundamental importance, meaning what really this I'm trying to say is that in contrast to some of the AI thinking in which they say that the brain is a truth maintenance system. Well, I don't think so. We do care about truth at a high level, but our brain is not a truth maintenance system. We don't care whether those narratives are true or not, and so on. And I would say that probably it's a late evolutionary development. So even the concept of some narratives are true or not are probably happened in historical time, not millions of years ago. Next, the second question is repetition the mother of all learning. So let's see how did the assumption of what Xapagy does. How does repetition would help? So we know that repeated recall reinforces a memory. So all this stuff like the Ebbinghaus forgetting curve and spaced repetition and Pimsleur approach and stuff like that. Well, yes. If you look from outside into Xapagy, then the more it recalled something, all those stories had been recorded, and once they had you had 6 identical stories, those are going to dominate the shadows, and it's going to make it more likely to be recalled. But on the other hand, these repeated recalls are not reinforcing the original memory. They just, if they are similar enough, they make it more likely to record something. So they are just adding independent memories, which means that the original recall, in fact, let's say you had an interesting experience and you recalled it and re-narrated it hundreds of times. Well, it's going to be easier to re-narrate it 100th time, but you actually lost details of you are less likely to recall exactly the way in which it happened. So again, I assume this is somewhat verifiable and leads to interesting things. Can we control what we recall? Well, recall is a bad name. We can have some control over the recall, like for instance, we can select different choices for the continuation, but then again, we cannot quite control the shadows. Now, can we control the shadows? Maybe in some very general ways. I don't know. You can decide whether I feel very specific now, or I want to daydream, or I can take drugs, okay, which changes the way in which how many shadows I have, or stuff like that. And of course, we can affect shadowing by altering our autobiography. So a number of these kind of brainwashing techniques, or whatever you want to do, self-conditioning techniques, where you keep telling yourself that I'm beautiful, I'm beautiful, I'm beautiful, I'm beautiful, even if you don't believe it. After a while, it's going to it is going to shadow in that way. Can we believe 2 things at once? Yes. These are stories, this is not logic. There is no problem, this is a repository, not a logical system. I can simultaneously entertain that Elvis died in 1977, or, no, not or, and he is on a pilgrimage to Shangri-La and will return in year 2000. So contradictory continuations on headless shadows, however, are going to make me undecided. Now, is there an autobiographical global brain? So, if my assumption I'm playing with is true, then if the human cognition is determined by my autobiography, then the global brain would be determined by the repository of all the narratives of humanity. And now we know that humanity has collected narratives in various forms, right? And we transfer our narratives down historically. Now, of course, we also know that we had retained different narratives in a selective way. For when we say that our civilization originates from the Greeks, it is mostly because the narratives of the Greeks had, from Plato's Shadows and to the Iliad and other stuff, takes a very large part of the collective narratives which had been passed down to us, and similarly with the narratives of Christianity and various other. Okay. So now, of course, because we had selected, right, we see these narratives from certain points of view, right? Or like Greeks were fighting with the Persians were just as civilized as the Greeks, except that their narratives had not been passed down to us or in a very, very cursory way, so we don't really know what they were thinking. Now, now the question, of course, is whether this system is active. And, well, humanity, so, now, is it active? Well, we have these narratives, but we don't have the system around them, right? So we are still using humans as still using the humans to process these narratives. The internet itself does not process the narratives. Now, one thing, again, reading some of the papers with regards to global brain, is that there is this challenge propagation model, and I had actually seen that it is probably conceivable that some, or maybe even a lot of these challenges at the global level are actually stories asking for a continuation. So a challenge is, this is the story, now what are you going to do about it? How are you going to continue the story in such a way that you want it to be, right? So in a way, Robbie had actually faced the challenge by seeing the story up to the moment when the commercial cut in, and then he responded to the challenge by imagining the continuation of the story. So how did the internet change all these things? Like this narrative had been passed around for thousands of years. Well, the way internet changed things is that the narratives are now in an active and searchable format on the web. Now, does this make the emergence of the global cognition possible? And, well, not with what we have out there, I think. But we can imagine that some of the things which we are doing out there are actually somewhat similar to shadowing, like what Google does by indexing things and say in a way that when you do a Google search, what Google gives you is the shadows of that little word or whatever you have done, right? It's looking up something related to it. So these are, of course, only loosely equivalent to shadowing, and of course the story is that what you pass on to Google is not a complete narrative, but just a couple of attributes. But it is somewhat in that direction. Okay, now, so what if a global brain emerges? And you can see the global brain, correct me if I'm wrong, like you can see it as a metaphor which had been around for a while, right? Just a collection of the things, but then what if these separated things are getting more tight, and you're actually going to have something which is less of a narrative, less of a metaphor, but like a genuine intelligence, connected intelligence. So now this is really far away speculation, but the question is what kind of intelligence this will be if it emerges? Well, again, we'll have the combined autobiography of humanity as a background. It's going to have a lot of indirect narratives because that's what you have. It won't have first-hand narratives at the moment when it emerges. Because it won't have the physical feedback which anchors our narratives at the bottom level. And probably will be initially confused about those. Now, so if the global brain emerges, it's probably going to have, like any other intelligence, to try to take actions and probably the main actions are self-preservation. So what kind of actions would it take? Well, this is again wide speculation. Well, one would think that it's a reasonable hypothesis that the autobiographical global brain will try to expand its own consciousness. And if the consciousness is defined by stories, it means that it's going to try to acquire more stories. Now, how would acquisition of more stories behave? Well, one of them would be, well, the Skynet, right? At the moment when you flip it open, immediately sends off the airplanes and blows everything up. That's unlikely because being alone in a planet does not make for interesting narratives. Then the other idea would be, let's make it the war, connect everything together, humans and so forth, control everybody's brain. Well, that would still probably won't happen because complete brain control doesn't make for good stories. Other thing is that it just hides and sees us as a theater. It will, again, probably not, because it will miss first-hand experiences, so probably it will want to participate. Very few intelligent people want to be just beepers. Will it be the guardian or angel? Well, if the global brain is constructed from the integrated autobiographies of all humans, it's likely that its ethical system, meaning that the way in which it judges outcomes, is going to be somewhere an average, a consensus of what our ethical judgments are going to be, because just how it works out. It will not, however, think that will position itself as a defender of any particular human